So looking at this one, if you remember from Tuesday, we were talking about simple interest. And our formula for simple interest, the amount of interest is equal to the principal times the rate times the time. Do we know the amount of principal? 2,000. Do we know the rate? 9%, so we're going to write it as 0.09. And the time? 4 months, so we're going to write that as 4/12, because the time is always in years. So if we do 2,000 times 0.09 times 4/12, bless you. Bless you good. We get 60 bucks interest. So that means at the end of our 4 months, we have the 2,000 plus $60. We have to pay back $2,060. How many of you had that? No? How many have no idea how I got it? You were here Tuesday? Any questions off the homework from yesterday that you want me to go back and go over?
We didn't have math yesterday.
Or from Tuesday?
13.
13, what page is that again? That's 97?
97.
So page 97, number 13. Larry purchased a new combine that cost $175,000. $175,500 less a rebate of $4,500. So we're going to subtract the $4,500. So what they're trying to tell us is that he actually paid $171,000 for it. He had a trade-in of $9,500, so we're going to subtract the $9,500, which is going to put us at $161,500, and a down payment of $5,000. So we're going to subtract $5,000 from that. So $156,500 is what he's financing. So he's going to finance the balance at 8% over 4 years. Find the monthly payment. So if you recall, our formula for monthly payment, we have to take the amount of principal, this would be the $156,500, times, ready for this? It's going to be our 8%, but it's got to be written as a rate. So 0.08 divided by 12, because it's per month now that we're going to be doing the monthly payments, times 1 plus 0.08 divided by 12, to the power of, how many months is this going to be? 4 years is 48 months. Then divided by 1 plus 0.08 divided by 12 to the power of 48 minus 1. So let's see what we get out of this. 156.5 times 0.08 divided by 12 times parentheses 1 plus 0.08 divided by 12, close parentheses, the power of 48, close parentheses, divided by 2 open parentheses, 1 plus 0.08 divided by 12, close parentheses, power of 48, minus 1, and close the parentheses, giving us $3,820.62. should be his monthly payment? You were good up to the 156.5? This formula here may be just a touch complex. I might not ask you to do that on a test or a quiz. Speaking of, there are some of you still working on the quiz, and please feel free to take as much time as you need to finish up. But we're going to hit our new material here quick to finish up Unit 2. A little bit different topic today. We've touched on it just briefly before, but we're going to take a look at something that looks like this. What does that mean? 8 to the 3rd power. Good. How do we calculate it? There you go. 8 times 8 times 8. It means there are 3 8s multiplied together, which would multiply up to 512. Now for 8 to the 3rd power, it wouldn't be too bad to do that on your calculator. It's just 8 times 8 times 8. But what if it were something like 5 to the power of 6? Might be a little bit trickier to keep track. How many times have I punched that in? So do you all know how to do a power on your calculator? No? Depending on your calculator, you might have 1 or 2 keys. Most commonly, you have a caret key. Looks like that. That one, if you're on the TI-30, it's off to the left side about halfway up. If you have the one-line display TI-30, you generally have this one. It would be on the right side, about the 2nd or 3rd key from the top. Both keys work the same. You would type in the 5, press that key, and then the 6, and it better give you about 15,625. Test it, see if it works. Does it work? Good. Okay, let's try another one. I'll race you. 2 to the 11th power. 2048? Perfect. Anybody not get their calculator to do powers? Okay. So calculating with the powers isn't terribly tricky to do. But when we throw in something like this, we have to be careful. Try that on your calculator, -7 to the 2nd power. Now, some of your calculators will do this without any problem at all. Some of them are going to try to tell us something silly like -49. If you have the one-line display, you'll get +49, right? Anybody get -49? Okay. You have to be very careful, especially if you have the 2-line display calculator. You do have to actually put the parentheses around the -7 and then do the power of 2. If you don't put the parentheses around the -7, it's going to try to tell you it's -49 because it'll apply the squared. It'll apply the power first and then put the negative on it. But if you think about it, -7 squared is just -7 times -7. And we've talked about this before. A negative times a negative is always positive. So what if we tried then, in fact, based on that, we know that any number squared is going to have to give us a positive answer. If I have -12 squared, it's going to be positive. It's going to give us positive 144. Try this one on your calculator. -9 to the power of 3. Did your calculator spit out -729? Okay. Is that right, or should that be positive? Well, let's look at it. -9 to the power of 3 is -9 times -9 times -9. If we were to do that out step by step, Of course, negative 9 times negative 9 would be a positive 81. Times another negative 9, well, positive times a negative is a negative 729. So negative 9 to the third power, it is possible for that to come out negative. How about, negative 12 to the third power? Negative 1,728. So when we have a third power, it is possible to get an answer that's negative. What if I do negative 4 to the fourth power? $256. Now again, that comes out to be positive. If we were to write that all out, negative 4 to the fourth power is 4 negative 4s being multiplied together. Negative 4 times negative 4 is a positive 16. Times the negative 4, well, positive times the negative is a negative. 16 times 4 is 64. Times another negative 4, and negative times the negative is going to be a positive, and that is 256. So you can see, based on that, anything to the power of 4, let's say I have a negative 7 to the power of 4, anything to the power of 4 is going to be positive. Well, let's try negative 3 to the power of 5. First of all, before you punch it in, can you tell me if it's going to be positive or negative? Negative. And why is that? It's the power of 5. That's going to be 5 negative 3s multiplied together. Negative 3 times negative 3 is a positive 9. Times negative 3 is a negative 27. Times negative 3 is positive 81. Times negative 3 is a negative 243. Do you see a pattern developing yet? So if I were to put up here negative 2 to the power of 7, is that going to be positive or negative? It's going to be negative because it's an odd power. Now, obviously, if this number in here were positive, it doesn't matter what the power is. It's still going to be positive. But when it's a negative number to an odd power, the answer is going to be negative. This will be a negative 128. Negative 5 to the sixth power, positive or negative? Positive, because it's an even power. The negatives are going to pair up and cancel out to be positive. So that's going to be a positive 15,625. Well, all the operations we've looked at so far come in pairs. We call them inverses of each other. What I mean by inverses is exactly this. One will undo the other. Addition and subtraction are inverses. If I pick a number, let's just pick the number 12. And I'm going to add something to it. I'll pick another, let's just pick 7. 12 plus 7 is 19. If I want to get back to the 12, I'm going to take my 19 and I'm going to subtract 7. And it'll take me back to 12. Adding 7 and subtracting 7 are inverses because they cancel each other out. One of them reverses the process. Likewise, I could have subtracted first and then added it back on and got back to where I started. Multiplication and division are inverses. Let's say I start with the number 15 and I multiply by 4. I'm going to get 60. Well, if I want to get back to 15, I'm going to take my 60 and I'll divide by 4, gets me back to 15. Multiplying by 4 and dividing by 4 are inverses. One of them reverses or undoes the other. So let's say I have 25 and I subtract 9 to get 16. To get back to 25, I would add 9. 16 plus 9 gets me back to 25. If I had 36 and I divided by 4 to get to 9, how would I get back to 36? Well, 9 times 4 puts me back at 36. So we've got the pairs of operations. Addition and subtraction reverse each other. Multiplication and division reverse each other. Well, now we have this new fifth operation, the powers, the exponents. There has to be a reverse of that. 9 squared is 81. If I want to reverse that, I'm going to use that symbol. We know that one is the square root. It's actually a radical symbol that can mean a lot of different things. In this case, since it's just used by itself, it is a square root. And the square root is the reverse of a power of 2. It's the reverse of squaring. So the square root of 81 is just 9, because 9 squared equals 81. Now, if you look at that really closely, there's a second possibility, because there's something else squared that equals 81. Can anybody tell me what that number is that when I square it equals 81? Negative 9. So when I do a square root of 81, we're used to getting the answer of 9, positive 9. But there's also negative 9 that's a positive answer for that. Now, for our purposes, we're pretty much always interested in a positive number, so we don't care about the negative 9. We're just going to take the positive 9 as our answer, because in real life, other than my checkbook, there's not a lot of numbers that are negative. So we said that 7 to the power of 3 is 343. How would I get that 343 back to a 7? Well, I'm using that radical symbol again, but I'm going to put this little 3 up there. That 3 is called the index of a root. In this one, there was no number there. It's implied that that's a 2. But since the square roots are so common, we don't put it in there just to save clutter. The 3 here tells us that this is reversing a power of 3. So it's saying what to the third power equals 743? Well, we saw it right up here. It's 7. Thank you. So the third root, or cubed root, reverses a power of 3. So if I tell you that, so let's look at the cubed root just a little bit more. Since the cubed root, then, let's do the cubed root of a negative 27. That's asking me what number to the third power equals a negative 27. Comes out to be a negative 3. Negative 3 to the third power is a negative 27. So we take the third root of a negative 27 and we get a negative 3. So if we go back to our square root up here, what would the square root of a negative 16 be? Negative 4? Would that do it? Let's ask ourselves. Negative 4 squared is what? It's a positive 16. That doesn't work. If you punch the square root of negative 16 into your calculator, and depending on which calculator you have, most of you actually have to do the square root symbol first. And it's a second function. You have to do second or shift, hit the square root key and type in 16. Actually, you'd have to type in negative 16 and hit equals. Or on the one-line display, you type in the 16 negative and then just hit the square root key. Either way, it's going to tell you error. Why is that? There's nothing squared that can give you a negative number. When we were doing our powers up above, anything squared was going to be positive. So because any number squared is positive, there's no such thing as a square root of a negative number. Now, I talk about that in terms in here because we're dealing with real objects and real numbers. If you were to get into like a college math class, college algebra class, I should say, At a certain point, they decided, okay, let's just make up an answer to that. The square root of negative 1 is going to be this letter I, and we're going to make up a whole theory of algebra based around it. We're not going to get into imaginary numbers in here. That's what they're called. But just so you know, if you were to go on into a college-level algebra class, you would have to deal with imaginary numbers. So if I give you that 5 to the power of 6 is 15,625. What is the sixth root of 15,625? Five, right? Could it also be negative 5? Yes, because negative 5 to the power of 6 could also be a positive 15,625. Now again, we're only interested in the positive answer for the most part, but be aware that there is a second possibility. The fifth root of a negative 243. Can I do a fifth root of a negative 243? Can I do a fifth root of a negative? I can't do a square root of a negative, but I could do the third root of a negative. Let's try the fifth root. To do a fifth root on your calculators, most of you have an n root key or an x root key, depending on what you have. For most of you, it's actually going to be above your caret key. So you have to do second and then hit the caret key. You got the x root right above it. So the way you would enter this into your calculator here is you would have to enter the 5 as the index of the root. Then you have to press second and then the caret key, which is your x root key, and then type in the negative 243. On the one-line display, I believe you do it exactly opposite. You put in the 243 negative, hit the shift and the x root key, and then type in the 5. Should give you a negative 3 if you do it correctly. Anybody not get it to work? Try this one, the 11th root of a negative 2,048. Negative 2? Perfect. How about 6th root of a negative 729? Get an error? You noticing a pattern here with taking the roots of negatives? Which ones can we take and which ones can't we take? This one worked fine. Why did this one work? Because this is an odd root. It's an 11th root. The 5th root worked for a negative number. The 3rd root worked for a negative number. We can take the odd roots of negatives because when we do odd powers of negatives, we get a negative answer. The even roots of negatives, like the square root and the 6th root, don't work because anytime we take something to an even power, the answer is always positive. So there's no way to reverse a negative if you can't get a negative result. Okay, well that wraps up Unit 2 for us. Next week on Tuesday when you come in, we will have the Unit 2 test. For homework for now, page 93, let's do 1 through 21, the odds. These should be a little bit easier than the amortization and annuity problems from Tuesday. Those are kind of ugly. Like I said, those won't appear on the test unless I give you some extra credit questions.